Vanakkam, welcome to Porvalan channel. Now we will learn to write a program to add two hexadecimal numbers which can generate a carry. Before we write a program, we need to decide a number format. So I am just choosing a random number, say an example 59 B2 and another number. It needs to generate carry. That's why I'm just choosing some bigger number. Say it is B619, some random number. So these two are hexadecimal numbers. So we need to add, because we need to verify whether the output will be output is correct or not. So 9 plus 2 is 11, it's B, it is C, and then next it's 15, that is 9 plus 6 is 15, that is F here. 11 plus 5 is 16, it is 1 0. So to make it as 16-bit number, I'm adding 3 digits of hexadecimal zeros prior to this 1. So this is one 16-bit number, this is another 16-bit number. So totally I am getting 32-bit hexadecimal number after adding these two numbers. So before we write program, we need to decide input memory locations also, because we are going to use direct addressing mode. So the input locations, I am choosing 5000 5000 to store my least significant byte of my first number, it is B2. And in consecutive memory location, I am storing the next byte also, it's 59, and 5002 it is 19, and then 5003 it is B6. Next, the output location we need to decide. The output locations, I am just choosing 5100 is CB, and 5101 it is 0F, and 5102 consecutively I am choosing. So 01, 5103 is 00. These are my input locations and these are my output locations as well as values. Now we will write program. So since I told you I'm going to use direct addressing mode, we are actually going to move the first input value. So move, I'm choosing AX, it needs to be moved to the processor. The first operand should be moved to the processor, and I'm moving the value stored in 5000 as well as in 5001. I'm just I have pointed out only 5000, I have addressed only 5000, but the value in 5001 also it's moved to AH. The value is there in 5000 is moved to AL, value is there in 5001 is moved to AH. And then next we need to add these two numbers, add AX directly from the number present in the memory location 5002. So the AL and AH, these two, it is stored in AL, this is stored in AH, and this is added with the value stored in 5002 as well as 5003. Right, I did not mention 5001 because it is there in AH, it is already stored. X means 16-bit register, so automatically the next memory location value also moved to this. This is how the opcode is being made, so we are not mentioning that. This is the format of instruction, and now we have added these two. But one important thing, we need to get the carry. So we need to make carry is actually a single bit flag. We need actually 16-bit number to make single bit flag as a 16-bit number. We need to follow a logic. That logic is, I am just going to initialize a register with 0, so that, say I'm just taking CX register, I'm just making into 0, we are clearing it, because if we don't make, I'm going to initialize this register, I have initialized as 0, I'll be incrementing if the carry is generated. If I don't make this into 0, then if I simply increment it, if there is any previous value stored already in CX register that will be incremented, then the entire output will be wrong. To avoid that situation, we need to clear a register. What we are actually choosing to store our carry. Fine. So cleared, and then after arithmetic and logic instructions only the control instruction where actually we are checking our carry can be written. So jump on carry or jump on no carry. I am writing jump on carry. There are two things to check your carry flag. One is jump on carry, another one is jump on no carry. So jump if not carry set. So if the carry is not set, what does it mean? Say the value is not bigger here. It may be like a 0. If it is 0, then 5 plus 0 it is 5. This entire number is not been generated if our input is like that. So what is that output will be? Then directly these two numbers will be the output. So the carry is not generated. We need to write both the conditions, whether the carry set or not set. The program should be written for the both the conditions, because we don't know how the input will be given by the user. So that is the case. I am choosing the first one as a jump on no carry. The carry is not generated. Then if the carry is not generated, we need to simply store. So this is the label, right? This is actually instruction, mnemonic or instruction in ALP, assembly language programming. This one is label. So store, simply we need to store, which means this indicates it jumps here. Generally in assembly language programming, I said in my previous video also, this is actually executed in sequence, right? This control instructions are actually changing the sequence of execution. Store, what has to be stored? The result is there in AX, so it is move direct addressing mode I am using. So 15100 is my output location. I have decided already. So it is the value which is there in AX is moved to 5100. And then next we need to move CX value also. CX, what is the value now? It is simply 0. 5102. It is moved. CX value is moved to 5102. So now there is no 1 here, it will be 0. And as per the condition, if the carry is not set, okay, there is no value there, which means I am not for any kind of input data I am talking about. I am not specifically telling about this number now. That's all. The program is over. But another condition, if the carry is not set, yes, we are storing and storing the AX value as well as CX. There is no carry in CX, so CX is already initialized into 0000, and this is actually stored in 5102. The program is over. But if the carry is set, what we need to do? We need to increment CX. So in our case, carry is actually set. So this instruction will not be executed. If this instruction is not executed, what will happen? Automatically this instruction is not executed, then this will be executed. Increment CX in the sense the CX register value is incremented. Initially we have 000 in CX register, now it becomes 0001. Now then automatically this instruction will be executed. This is a label, right? So this instruction will be, because I said it is sequence one by one execution, only the control instruction can change the execution order. So AX value is stored in 5100, CX value now becomes 0001, because in our condition, in our example, we have carry. If the carry is not there, say for your clarification, if the carry is not here, then this value will not be there. It is actually 5 and this is becomes 0, right? And this actually 5FCB. So in that case, this instruction jump on no carry is actually true. Condition is true. Then this instruction will not be executed. It is actually skipping this instruction. It comes to this instruction. Then AX is stored and CX value is 000, because it is not incremented. It is not executed and program is over. This is direct addressing mode. In that case, why can't you use JC? There are two things we said, no? Jump carry, jump on carry, jump on no carry. So if jump on carry is used, then what happens? I write the same thing. You can just have the same thing here and then now I am just checking, right? This instruction, jump on carry. If carry is set, in our case, yes, we have chosen B, right? It is 0. Now it is there, right? So this is 0F, right? And this is 1. In our case, now carry is set. Then what to do? If carry is set, we need to increment. So we need to make logic in proper way so that both the conditions satisfy. You may choose this instruction, jump on no carry, or you may choose jump on carry. If carry set, do this. If carry doesn't set, then do this. You can choose any instruction, but the instruction what you choose, right? Based on that, you need to make the logic, right? Creating the logic. You need to create the logic. You need to write the instruction based on that. Fine. So if the carry is set, what we need to do? We need to actually increment. So I am writing the label as increment, right? So increment, fine. Increment, what it needs to increment? It needs to increment a CX register. So right, increment goes where? So here it is. Increment, this label, it jumps from here to here, right? INC CX, it needs to be incremented. Now what is it? CX actually initialized to 000. What is it? Move CX comma 000. The same thing is there. This instruction also same. This instruction not this. That is move AX comma 5000. Move sorry, add AX comma 5002. Right now, increment CX. Yes, CX becomes 1 now. We need to store the result. So move the value 5100, that is AX into 5100, and then next move 5102 comma CX, and then halt. This is for the condition if the carry set. We are incrementing. Initialized it was 0 and now it is incremented. AX value is also there. This is the AX value. This is the CX value now, and it is stored. 5100 as well as 5102, 5101, 5100, 5101, 5102, 5103. Like this, it has been stored. Fine. If carry is not set, because I have chosen this thing, if carry is not set, what should I do? This will be ignored. If the condition, if the carry is not set, in our input it will be set, but if the condition is not set, what will happen? It will be ignored. So what we need to do? We have written in this sequence, so we need to make this this sequence to work for both the conditions. So what I am going to do is, I am just going to reinitialize my CX register as with 4 Fs, FF, FF. Now instead, initially it is 4 zeros, okay, and at this point I am reinitializing into CX, that is same register, into FF, FF, FF. See, if the carry is set, this instruction will not at all be executed. The carry is not set, only this instruction will be executed, because I made the sequence. So I have to use this sequence for both the conditions. So for that I am making this, because my logic is, see, if I just increment it again, this FF plus 1, then what will happen? 1 plus 15, it is 0, carry 1, again it is 0, carry 1, it is 0, carry 1, it is 0, carry 1. This carry is gone. It is set in carry flag, but we are not checking, or we are not retrieving that carry flag. It is not required, so it is incremented. Now this CX register becomes 000 if carry is not set. So this AX value is moved here, CX value is moved here. So now this CX value is become 5100. Actually the CX value is become 0000, not 1. Okay, it is in 5102, it is 0000. This is how we need to write. The same thing can be written in register indirect addressing mode. If it is used in register indirect addressing mode, then what we need to do is, I'll write it again. So we are initializing cx into 0 0 because to get the carry. Next we are initializing input address 51 say 500, and then we are initializing the output address 5100, and we need to move the first value EAX I'm choosing, so it is, we cannot use this, so SI. So the SI is a register which has the address 5000. From that address 5000 as well as from 5001, the values are moved to AL as well as AH. X indicates always 16-bit register. Yes, in this general purpose 4 register AX, BX, CX and DX. Now I need to go to the next memory location, that is next input, right? So here SI is pointing out only 5000. So if I need to increment this, increment SI. What is SI now? SI is having 5001, but actually 5001 is already been moved to AH. Now I need to increment it again so that I can make my SI register into, it was 5000, at this increment it has become 5001, at this increment it has become 5002, right? Now SI becomes 5002. Now add AX with content of SI, which means the value in 5002 as well as in 5003 both will be added with AL as well as the values in AL as well as in AH, right? Now jump the same thing, jump on no carry, we need to store, so it is a label move, same thing, move DI. Now instead of 5100 I am writing DI, the AX value is moved, and then next the CX value has to be moved. So here we need to write increment CX. If the carry is set, it needs to be incremented. This is ignored, it is incremented. And then we have to go to, this is 5100. We need to go to 5102, not to 1, right? So INC DI INC DI 5000 5101 5102. This is correct. So move content of DI comma CX. Now it is incremented, because in our case if it is not set, sorry, if it is set it is incremented, if it is not set it is skipped, then this becomes 0000, right? So halt. So if carry is set, if carry is set, what happens? 5100 is having the output of, what are the outputs? This thing 00, sorry, the 0F CB, okay? So it is CB 5101, it is having 0F, and 5102 is having 01, 5103 is having 00. Not set, if carry is not set in your input, if you just give such kind of input, then what would be the output? 5100, it is CB, right? Say such kind of input in the sense, for this input what is it? It is 59B2 B619. If the input is 59B2 B619, then it is 0001 and 0 FCB. This would be the output. If the input, say an example 0 1 2 3 5 6 1 6, something like that, okay, carry is not set, definitely now the carry is not set. So add this thing 9, say I just put some number 0723, because we need to have some hexadecimal identification there, and 510123 also, it's nothing wrong, you can use that. Fine. 3 7 plus 6 13, 13 is D, and 0 plus 5 is 5. Now carry is not set, so in that case, so here we have 3 9, yes, 3 9. So 5101, here we'll be having 5D, and 5102 will be having 00, 5103 will be having, and again 00. This is how we need to write program. We need to understand the logic, and we need to create a logic and understand, right? And we need to write a sequence of instructions. We need to construct it, we need to assemble it, and we need to make that as a program. That's why it is called as assembly language programming. Hope you have understood well. Thank you.